Right, so in this video I'm going to have a look again at the 2016 Maths Higher Level Paper 1, and I'm going to have a look at questions 5 and 6. So this is the first question here, question 5A1. Now this is a right angle triangle here, and we're going to end up using Pythagoras Theorem. The question is, the lengths of the sides of a right angle triangle are given by the expression x minus 1, 4x and 5x minus 9. Find the value of x. Well, you can see it's a right angle triangle, so we can form a simple equation here with x's, and we just solve for x. So let's do that. So we know that x minus 1 all squared plus 4x all squared should give us 5x minus 9 all squared by Pythagoras Theorem. So let's just multiply all of this out. We're going to get x squared minus 1x minus 1x minus 2x plus 1 plus 16x squared on the left hand side. And then on the right hand side we're going to get, let's see, 25x squared minus 90x, I think should do it, 45, yep, minus 90x and then plus 81. Okay, so let's put all that together. What I'll do is I'll bring everything over to the right hand side. Oh no, wait now, let's see, yeah, 16x squared, 17x squared on the left, 25x squared on the right. So yeah, I'll bring everything over to the right hand side, and I end up with 8x squared on the right hand side, minus 88x and plus 80. Now I can divide across by 8. I'll get 0, x squared, 11x and 10 here. Okay, good. So I can just simply solve this. This is a quadratic equation, so I'll get, let's see, x, I need 10 and 1 will give me 11. I have a plus, so it's going to be minus times minus. That will give me x is equal to 10 or 1. Now if I look at the triangle, I have a choice of 10 or 1 here. Now if I put a 1 in here, I'll end up with 0. I can't have a triangle here with a 0 length, so I'm going to go for 10 here as my answer. So x is equal to 10. Okay, now do they give us dimensions here? No, okay, or sorry, units I should say. No, okay, so the answer is 10, that's it. Okay, let's move on to the next part. I think I'm going to run out of a little bit of room at the end. I might just move this up a little bit to give myself some more room at the end. Now verify that this value of x, using this value of x, that the lengths of the sides of the triangle form a Pythagorean triple. So all we got to do is change the lengths into lengths with x's to lengths with actual numbers. So get rid of the x's, in other words. So one of the sides was x minus 1, so that's going to be 10 minus 1, that's going to be 9. The other one was 5x minus 9. 5x minus 9, so that's going to be 50 minus 9, which is 41. And the third side is 4x, so that's going to be 4x here, so that's going to be 4 tens, which is 40. So this one and this one here, they're the two short sides, so let's just square those. We get 9 squared, 40 squared, and that should give us 41 squared. Well, that will give me 81 plus 4 4 16, and 41 squared is 1681. These two together gives us 1681 equal to 1681. So these three numbers here, 9, 41 and 40, do form a Pythagorean triple. Okay, so that's part 2. Let me just grab this and move it up a little bit as well. Okay, so let's see. Just move it up a little bit further. Okay, now what does this say? Let me see. Show that f of x is equal to 3x minus 2, and that is it's an injective function. Okay, so injective functions then are one-to-one functions. In other words, each output is the image of a unique input. So if we just take some values and actually draw, there's a number of ways of doing this, but let's take y as 0, y is equal to 0. That will give me x is equal to, let's see, if y is 0, I'll get 2 over 3. So one point here will be 2 over 3, 0. Just going to plot 2 or 3 points here. Let's take x is equal to 0 here. That'll give me y is equal to minus 2. So another point would be 0 minus 2. Let's just pick one more. Let's say x is 1. Okay, x is equal to 1. That'll give me y is equal to, if x is 1, you get 3 minus, yeah, y is 1 as well, so we'll just have 1, 1. Now if I draw that, I will get some kind of graph like this. It's going to be fairly rough and ready, but let's see, minus 1, 1, 2, 3, let's go to 4 here. We'll go 1, 2, 3 here, let's say minus 1, minus 2. Okay, so we have 2/3, 0, so I'll just put it in a different color here. So 2/3, 0 is somewhere around there. Let's see, we've 0 minus 2, so that's going to be here. And then we've got 1, 1, which is here. So if we join those up, we will get a straight line. Doesn't look very straight here, but you know, you could use a ruler here, do it properly. Anyway, you can see that using, for example, the horizontal line test here, that if we have any horizontal line going across, we'll only hit the graph in one place. Okay, it only hits the this line here in one place. So that's a test for injectiveness. So each output is the image of a unique input. Now also what we could do here is, let's say, take any two elements of OR. Let's say take A and B. So any two elements of OR. I'll do this in white here. So we're going to take A and B as our x values and stick them into the function here. So in other words, f of A here will give us 3a minus 2. F of B will give us 3b minus 2. So if the two y values were the same, so we're going to let the two y values f of A equal to f of B here. So that means 3a minus 2 would be equal to 3b minus 2. That will give me 3. That will give me 3a is equal to 3b. That will give me a is equal to b. So that shows that no two domain values get mapped onto the same output. So there are a couple of different ways of doing that particular question. Okay, so let's move on to the next one then. This is, let's see, I'm going to have to move this up a bit as well. Let's see. Let me just move it up a little bit here. Okay, so this is a function f of x equal to 3x minus 2, where x is an element of OR. We want to work out a formula for the inverse of this function, and show your work here as well, of course. So let's have a look at this. Now, so we want to, for example, put a value into this. Whatever answer we get, put it into another function, the inverse. We should get our original value back again, if you like. So what we normally do is, if we look at f of x here, if we take our f of x, what are we actually doing? We're multiplying by 3 and subtracting 2. So what we want to end up with is adding 2 and then dividing by 3. So what we want to do, if we multiply by 3 and subtract 2, our inverse of x should end up, we take our x, we're going to add 2 and divide by 3. That's what we should end up with. But how do we actually do that? Well, let's see. If we take y is equal to 3x minus 2, what you really want to do is write this in terms of x. So let's take 3x is equal to y plus 2. So we just took this 2 and brought it over here. And then we're going to divide by this 3 here. So it's y plus 2. We're going to divide by 3. So this here is going to be our inverse function here. This bit here. So what we end up with is f inverse x is equal to x plus 2 over 3. So for example, if we take a number and put it into f of x, so say for example we take let's take the number 2, so let's do f of 2. F of 2 will give us 3 times 2 minus 2, that's 6 minus 2, which is 4. Now if we take that 4, f, and put it into the inverse function, that will give us 4 plus 2 divided by 3, which will give us 6 divided by 3, which is 2. So we end up with our original x value again. Okay, so that's that bit done. Let's move on to the next question then, which is question 6. So this is, from what I can remember, a differentiation from first principles. Let's just take this, move it up a bit again. Whoops. I'll press another button here, there you go. Okay. Okay, there we go. So we have this function here, this 2x plus 4 all squared, and we want to differentiate this from first principles. So let's start. Okay. So I'll just write it down as f of x first. The function, we'll call it f of x. So I'm going to say f of x is equal to 2x plus 4 all squared. Well, the first thing we do is, well actually what I'm going to do is multiply this out first. That'll give me 4x squared. 4x squared plus 16x plus 16. Let's see, 2 4 is 8, 16, let me just double check, 2 2 is 4x squared, yes, that's okay. Now we're going to add a h here, so we're going to do f of x plus h. So that will give me 4 of x plus h all squared plus 16 of x plus h plus 16. Now you can multiply all of that out. That will give me, let's see, 4 of, let's see, x squared plus x times h plus x times h. That's 2x times h plus h squared. Here we get 16x plus 16h and plus 16 here as well. Let's just multiply this bit out. So we get 4x squared plus 2 4 is 8x h plus 4h squared plus 16x plus 16h plus 16. Okay, can I add anything here? I don't think so. No. Okay. So now what I've got to do is subtract these two. So this is going to be f of x plus h minus f of x. Okay, now, so what I want to subtract here is, I want to subtract all of these. I want to take all of these and subtract these three here. Now, if I look at this, I've got a 4x squared here, and I'm going to subtract 4x squared here, so I'll get 0 there. That'll disappear if you like. I've got a 16x here, I've got a plus 16x here. If I subtract those, they will disappear. And I have a plus 16 and a plus 16 here. That will disappear as well. So what I end up with is 8xh plus 4h squared plus 16h. Okay, perfect. Now, next thing I need to do here is divide by h. So I'm going to take the f of x plus h minus the f of x, and I'm going to divide by h. So if I divide the right hand side by h, I get 8x plus 4h plus 16. Okay, now the next thing I need to do, or the last thing I need to do really, is just to get the limit of this. The limit of f of x plus h minus f of x all over h, and I want h to approach 0 here. So if h approaches 0 here, I'll get 4 times 0 here if you like, and I'll end up with 8x plus 16. And that's it differentiated from first principles. And you can double check that by doing, we started with f of x equal to 2x plus 4 all squared. So differentiating that using the chain rule will give me 2 times 2x plus 4 times, differentiate what's inside the bracket, we'll get 2. So that will give me 4. 4 times 2x plus 4, that will give me 8x plus 16. So it works out. I got the same as what I got here, so that's fine. Okay, perfect. That's differentiation from first principles. Let's move on to the next one. Now I'm coming near the end here, so I just need to move these up again. Okay. Now, so this is a differentiation. So we have a function here, y is equal to x times sine 1 over x. So this is two functions of x, if you like, multiplied. So we're going to use the product rule here to find dy dx. So let's do that. We know from, well, it's in your maths tables anyway, dy dx. dy dx is just going to be u dv dx plus v du dx. Now if we write down the different values here, so we're going to say u here is equal to our x, so that means du dx is just going to be 1. V here is going to be sine 1 over x. So dv dx here, we've got to use the chain rule here. If we differentiate sine, we get cos, cosine 1 over x. But if we must differentiate the 1 over x as well. So if you just have a look at that, 1 over x is x to the power of minus 1. So differentiate that, bring the minus 1 down, we get minus x. And then subtract 1 from the power, we get minus 2. So it's minus x to the power of minus 2. So that will give me minus x to the power of minus 2. So really that's just, I'll put it in here, minus 1 over x squared. So minus 1 over x squared. Okay, so these are the different things we need to put into this formula here, so let's just do that then. So dy dx is going to be u, which is x. Du dx is just 1, so I multiply that, so I'll just leave it out. So it's going to be x. No, sorry. Let me just go back here a little bit. It's u dv dx, u dv dx. So dv dx is this here. So that's going to be minus 1 over x cos 1 over x here. Okay, so that's a bit better. So now plus v here, which is sine 1 over x, and this is multiplied by du dx, which is 1. So that's it here. We get, let's see, this is 1 over x squared here. I left out the x squared. So if we multiply this out here, we get x times minus 1 over x squared. That will give me minus 1 over x here. And cosine, so it's going to be cosine 1 over x as well, plus sine 1 over x. Okay, and that's it really. I mean, you can swap these around if you like. Sine 1 over x minus 1 over x cos 1 over x. So you can leave it like that. Just have the minus in the middle here rather than at the beginning, but that's really it. So that's that differentiated. Now we're going to use this in the next part, I believe. So let's have a look at that. Okay, so let me just move this over a bit again. Now, what we have to do here is find the slope of the tangent to the curve when x is 4 over pi here. So now the slope of a tangent to a curve, this is the slope here of any tangent to this particular curve. So we just got to put the x value in here, here, and here. So let's do that. So I'll just write down dy dx first. So our dy dx, or our slope if you like, is sine 1 over x minus 1 over x cosine 1 over x. Now, we want x to be 4 over pi here. X is 4 over pi. So let's just put that in. So our slope then, our slope of the tangent, nt rather, tangent, just write that tangent. Slope of our tangent at x is equal to 4 over pi is sine of 1 over 4 over pi minus 1 over 4 over pi cosine 1 over 4 over pi. Okay, so let's work all that out. So we have the sine here of 1 over 4 over pi is just sine of pi over 4. Just flip this upside down and multiply if you like. Do the same here. That's minus pi over 4 multiplied by cosine of pi over 4. Okay, so let's just have a look at that then. Now, sine of pi over 4. So pi over 4 is 45 degrees. So the sine of pi over 4 is 1 over root 2. You can look that up. It's one of your special angles, if you like. It's in your maths tables. So you can, or you know, pi over 4, 45 degrees. So it's going to be, so it's 45 degrees or pi over 4. So this and this are going to be the same. Okay, so if this was 1 and this was 1, if by Pythagoras Theorem, this will be root 2 here. So the sine of pi over 4 here is just 1 over root 2 minus pi over 4 times the cosine of pi over 4 is also going to be 1 over root 2 as well. So we have minus pi over 4 times 1 over root 2, and then we have plus 1 over root 2. Now the question, I think, asked us to give your answer to 2 decimal places. Okay, so this again, this is just calculator work at this stage, so you can stick this into your calculator and you'll get 0.1517 and then to 2 decimal places, then that's going to be 0.15. Okay, that's it for those 2 questions. I'll do the next few in the next video.